Greetings, M Squared here. Today we are going to talk about some more linear equations, but this time variables are on both sides. And before we get started on that, we're going to do a little what do you wonder, what do you notice kind of thing. If you look at these equations, I need you to notice things. Anytime you look at an equation, before you start to solve it, you should wonder and notice. And you should especially look at the variables, because we are learning about two different types of linear equations, one with x on one side and one with x's or variables on both sides. So what I would notice, I'm going to take my little highlighter here. I'm just going to notice the x's. What do you notice? Well, on this first one, I noticed that x's are on both sides. Not only that, but I noticed that on this side, the right side, x plus 2x is actually 3x. So if I was simplifying that, I would get this. Now, what do you notice about that? The x's are exactly the same, but the numbers are different. So if I got all my variables on one side, if I subtracted 3x from both sides, they would actually cancel out, because 3x minus 3x is 0. And I would be left with this. And this is a false statement. This is not equal. 7 does not equal 5. There are three things that can happen when you solve linear equations with variables on both sides. You can get a no solution, you can get one solution, or you can get an infinitely many number of solutions. A false statement always goes back to a no solution. If you get a false statement, you know there's no way that could happen. Now go back and check, make sure you didn't make any mistakes, because this will definitely not happen as much as getting one solution. But you want to go back and look, plug something in. A no solution will always, the variables will always cancel out, and you'll be left with a false statement. On a one solution, the variables do not cancel out, and you will end up with an x that will be equal to some number. And in an infinitely many solutions, it's kind of like the no solution in the fact that there's a 3x on both, right? If I distribute that 3, I get 3x minus 12 equals 3x minus 12. And you should notice if it's exactly the same. If it's exactly the same, then you could plug in anything you wanted, and it would be exactly the same. For example, if I plug a 2 in, that's 6 minus 12. Well, then guess what it's going to be over here? 6 minus 12. So if it's exactly the same on both sides, exactly the same, then it's a infinitely many solutions. That means anything you pick can work. Now, it doesn't always look exactly the same, right? We might have to distribute to show, to notice, I should say, that it's exactly the same, but it's exactly the same. So what would you write here to show that this equation was a no solution, a one solution, or an infinitely many solutions? Well, infinitely many is going to be exactly the same. So that's a no-brainer, right? It has to be exactly the same. I mean, you could write that in different ways if you want to be creative. If you're like up a level and you're like not satisfied with the status quo, you could have written it like this, right? 4x minus 2. That would still get me if 4 times x minus 2 is the same as 4x minus 8. So be creative if you want to, but remember, it has to be exactly the same. In this case, you could put a lot of things here. The only thing you can't have on the right side is a 4x. Anything else is acceptable. You can put x plus 7. You could just put 20. You could put anything, but you cannot have a 4x over there, because then the variables on both sides would be the same, and that's a big no-no, because that happens in these two cases, but it does not happen in this case. Over here, the x's have to cancel out, so I have to have a 4x. Again, you can be creative and say 1x plus 3x, but you have to have a 4x, and then any other number except what's there. So you could have plus 7, minus 22, plus a half, or you could just leave it blank, because then they won't be exactly the same. Okay? So variables are exactly the same, numbers are different. Can't have the same variable on both sides, and exactly the same variable and constants on both sides. So your job, part of your job, is going to be to fill this out without solving. That means we're just noticing and wondering. We're looking and saying, oh, 3x and 3x minus 2 minus 2. That's exactly the same. I wonder which one that is. So your part of your homework is going to be to complete page 12 in your note packet and just look and say, I wonder if it's no solution, one solution, or infinitely many solutions. Good luck with that. M Squared signing out.